Located on the third ring of Beijing, China's central business district, just east of the Forbidden City, China's Central Television Headquarters, referred to as CCTV, is a unique dynamic skyscraper that has become a contemporary icon to the city and its people. Rem Koolhaas and Elise Shireen of OMA created the design of the 54-floor, 768-foot high skyscraper. ARA provided the complex engineering design that made this building a structural feat. The unorthodox skyscraper was a new prototype, another concept of skyscraper. The typology of today's skyscraper is a piece of land extruded in the vertical direction, with typically the sole goal of being the highest, the tallest, the most dominant in the skyline. This typically seems to create individual communities on each floor, independent and unrelated to one another. Rem Koolhaas wanted to create a single system where all activities and programs are concentrated and there is a coexistence of all functions that are involved in the television making process. These functions are administration and management, production studios and news departments, research and training divisions, and technical areas and broadcasting centers. This concept informs and allows all parts and departments, managers, and workers to be aware of one another, that they have mutual dependence to each other. There are hierarchies, but the building is not broken into different sections, but is a loop of communal circulation with associated areas, canteens, and meeting rooms in between. Even the VIP administration has a public lobby open to all who work there. The program organization is a continual structure, not a vertical one. This idea of the loop became the driving concept to the form. The CCTV building consists of four structural elements, which altogether create a continuous rectangular tube. Two towers lean towards each other at 6 degrees about both axes and are propped together or connected by the L-shaped overhang section. At the base of the towers, they are connected again by a complementary L-shaped section, thus completing the loop. The primary structure of the CCTV is the triangulated surface of the loop. This acts as a megatube element that has inherent benefits of stiffness, redundancy, robustness, and torsion capacity. A network of diagonals triangulates the surfaces of the building, distributing the loads up to the face, to the roof, and the underside, creating what they call a diagrid. Because of the complex geometry of the loop, different areas are subject to different degrees of stress. To ensure the load is approximately the same throughout to create maximum efficiency of the building's performance, diagonals were added where stress and force were greater and eliminated in areas of overcapacity. The result created this irregular diagonal grid that reflected the true stress pattern the structure would undergo during different loading conditions. Stresses from everyday stresses to severe earthquakes. The facade is a conceptual extension of the complex structure of the building, visually expressing itself on the exterior. The diagrid structure is mirrored and expressed by recessed steel profiles that dissect the homogeneous glass curtain wall panel surface. The result? Seemingly independent floating glass diamonds that adds differentiated scales to the overall geometry of the building. Each diamond acts as a single stiff element that is suspended from the steel profile. Because the glass spaces between the primary structural nodes, global structural movements on the facade are minimized. This allows for small joints within these glass panes, and the larger joints can lie along the recessed steel profiles. The glass is laminated and insulated with a low E coating and an integrated layer of expanded metal mesh. This mesh acts as microlouvers or sunshades. The mesh diffuses direct sunlight and provides glare control, but there are also internal blinds that can be deployed to further control sunlight and heat gain. In the daytime, the metal mesh glass allows the building from the exterior to appear monolithic, redefining and further emphasizing the bigness of the loop. While from the inside, the skyline of Beijing is clearly visible when looking out. tube and the diagonal grid are the primary structure. The floor plates act as internal diaphragm stiffeners to the tube. Internal core columns, trusses, and floor elements carry gravity loads. Three elements make up the tube mesh structure: diagonal braces, columns, and perimeter beams. The diagonal braces primarily support the building's overturning and gravity shear forces from everyday loads and seismic forces that occur in an earthquake. These braces are essential components to the building's structure. The braces are box sections fabricated from welded steel plate varying in thicknesses from 1.5 to 4 inches. Second in structural hierarchy are the columns. These benefit the structural weight and flexibility by providing direct load paths for the push-pull forces on the towers. Because the forces vary around the building, there are 6 types of columns used. The columns vary from steel H sections to steel reinforced concrete, which also consists of steel H sections that are embedded in concrete. The H sections are comprised of welded steel plates, also varying between 1.5 and 4 inches. And last on the structural order are the floor edge perimeter beams. Their job is to carry the floor loads and assist in the triangulation of the tube, especially at the overhang. These are rolled H sections that are the smallest of the structural elements. The foundation of each tower is a 330-foot long by 330-foot wide by 25-foot deep cellular reinforced concrete raft supported by 170-foot long piles. The foundation is offset from the tower's base, creating a toe to assist with overturning forces. The tube structure assisted in the ease of the construction of the building. The brace tube provided the necessary stiffness the leaning towers needed, allowing them to be built safely before the 2 towers were connected. The timing of the connection between the 2 towers was crucial. It was critical that there was minimal relative movement from thermal or wind effects between the 2 towers. The time to connect had to be early morning on a calm day, so the structure could be at a uniform cool temperature. This site not only contains the CCTV, but also contains the Television Cultural Center, referred to as the TVCC. Some of the programs inside the TVCC are a theater, audio studios, digital cinemas, a grand ballroom, and a 300-room hotel. Also on the site is the Media Park. This is designed for public entertainment, outdoor filming locations, and event spaces. Occupying the site to the northeast is a large 2-story ring-shaped service building that provides central energy to the building on site. The entire campus takes up 4 blocks. These 4 blocks have a common uniting texture, Piranesi's drawing of the Roman city. This is architecturalized through vegetation and landscape and built functional elements around the site. Thank you for listening and watching my video. I hope you enjoyed it.